I have shared the presentation today. So it talks about all the data analysis methods available on SAS Enterprise Miner, right? So in case, even if you later on you are not able to attend classes, you know exactly what can be done through Enterprise Miner. So I have given you a data set called state, latitude, longitude. Okay. So that is nothing but there are three columns only talking about state names, right? And latitude, longitude of the state, right? Why we are going to use that data? You remember that in the insurance data set, we have a state column, right? Talking about Andhra Pradesh, Arunachal Pradesh, Odisha, Bihar. So different customers were from different states, right? Then why do we need to combine that data set together, right? So if you go here, okay, I have not shared my screen. Just a moment. Where is that? Yeah. So my assumption will be you can kind of look into different options, at least on the data, what are the options available, then on the graph part, right? So I'm not going to go one by one. It will take a lot of time. Our main focus will be on the using different tools or techniques for predictive analytics. So these are basically for the descriptive analytics when you are showing certain information through visualization, right? Which is the descriptive part of your analytics. So I'm not going to go one by one, right? But one thing I wanted to show, which is on the bubble plot, where you need, if I just click on this bubble plot here, if you see, not on the bubble plot, sorry, on the under the mapping part, click on the map. So go to this task, click on task, under task, click on this map, right? Under map, anything you want to create, right? Let's say I want to create a bubble map. Taking a little bit of time. Yeah. So anything you click here under map, you need information on latitude and longitude, right? Though in this particular case, we will not have a get very good visualization, but I wanted to show you in such cases where you want to plot something on the map side, right? If some of you have taken Tableau, it was very easy, right? If I just say that, okay, I have certain sales on New Delhi, Mumbai, Kolkata, Bangalore, Chennai, right? So I need not have to search for latitude, longitude, right? I need not have to put latitude, longitude information. Even in the Power BI also, right? If some of you have gone through the Power BI course, what happens there? If I just give the name, so they have the map data or the geographical information system data inbuilt, which will help you to tag that location, right? You need not have to include the latitude, longitude data there. But in case of wherever, in case you are working on R Python, maybe you can get a module where already longitude, latitude data is available. But again, it has to be inputted, right? You have to input those data manually or through code, right? So let's say I want to create certain map view. I want to understand how my customers are divided, how my customer profit or whatever charges are divided across India, right? I want to have a map view, right? So in this particular case, what will happen? I do not have the information right now. I have the insurance data only, which was available on the, if I go to my library. So for you, just see that where you have that data stored, right? I had on this 2021. So if I click on this insurance data, I have the information state, right? Andhra Pradesh, Arunachal Pradesh, different states, but I do not have information on the particular location data on that, right? But in the SAS, if I want to build a visualization on map, then I have to include the location data also, right? So that's what I've done. If you search on internet, so I just got the information. Actually, I had that information from last year, right? Now, if you want to build also, you just go and search on internet state latitude and longitude of Indian states, second or third kind of site which comes on Google, it will give a table which includes the state names, latitude and longitude details, right? So I have just copied that data into Excel file, and that data I have shared with you, right? So I have already kind of run that file. So what you can do, whichever folder you are managing, right? Go to your server files and folders, whichever file. So in my case, where is that? PAUS 2021. Okay. So upload the file there. Okay. So whichever file for you, upload the file there. Then just double click it, right? So once you double click it, you'll get this file, right? State, latitude and longitude. The file which I have given to you, that is Excel file. This part we have already discussed. In the SAS, if you want to work, right, we need to convert that into a version which SAS can read, SAS readable format, right? That is that SAS P7D80, right? Everybody is able to do this. Just upload the file and double click it and run it. So this is the run symbol. So that will simply convert your Excel file to the SAS file. Anybody who has not done it? Anyone facing any issue uploading the file and running the file? Remember why we are doing this. We want to create a visualization, right, on the map view, because we cannot create without latitude longitude data. We have a file, insurance file with state names. There we are including the latitude and longitude data, right? Anybody who's not able to complete that? So first task is to upload that file wherever it is, right? So into the folder which you have created in the previous classes, right? So for me, this was the folder, upload files. So I uploaded that file into my folder. This is the state, latitude, longitude file which I had sent through Google Classroom. I'll just double click it. Once I double click it, output data, I can change the location also. I will change it to my library. Dataset name, I'll put latitude, longitude. Okay. So I'm storing this file, storing this SAS file. So that output path I'm giving, right? So now I'll run it. So it is nothing but that information which I've given you in Excel file, right? I just converted that into the SAS file path, right? So once I complete this, so this file is ready, right? So I can go and check that in my library. So this lat longitude file is there, then my insurance file, my original file which I worked in my previous class. What I need to do now, I have to combine those files. To combine that files, I have an option here in task and utilities. Go to task, under data, there is something called combine tables, right? So if you have two set of data, right, we need to combine. So like in Tableau, we used to carry out join operation, right? Similarly in SQL, if some of you have used SQL, Same thing we are going to do. So what is my first data table? My first data table is my insurance file. Last class what we worked on. What is my second data table? That is my latitude, longitude. Okay. Select the combination method, right? So if you see match merge, it is like the joining operation, right? So it will search for a column name. If that same column is available, right? So it will match, right? Then only it will merge, right? If there is no matching columns, it will not merge, right? One-to-one merge is basically if you have X number of data, Y number of data, irrespective of whether name is matching or not, it will merge, right? Match merge, if it is matching only, it will merge. One-to-one, if you have two columns of data or two table of data, it will one by one, it will merge, right? Irrespective of whether it is matching or not. Concatenate is basically when you are creating. So here basically what happens, you are depending upon what kind of merge you are selecting. Either your first table will remain with certain changes or your second table will remain with certain changes, right? Concatenate is where you are creating a new output data table combining the both the tables, right? It is similar to one-to-one merge, but one-to-one merging happens row wise. Here merging happens on the column side, right? Vertical. Here horizontal, right? In one-to-one merge. In our case, what we are trying to do is basically we are trying to find out the state names, right? Which is available in our insurance data, and trying to bring that latitude longitude data in our first table, right? In our first table, which is information is the insurance information. That information, if you remember, gender, smoking or not, number of children, how much premium charges have been given, BMI, all those information. We do not have person's name, but we have serial numbers, right? 1 to like 1338 rows. For each of them, we have also state information from which location that person is from, right? In the second only, there are three columns: state, latitude, longitude. So what we are trying to do, we are trying to match the name state, right? So that is why important. If the column names are different, then it will not match merge, right? Make sure that whenever you are using match merge, that column name need to be same, right? Here state, there also state. So match merge selection. Then there are different merging type, right? Only matching rows, right? So in that case, that is the inner join. Whatever is common, that will be only kept. Balanced data will be thrown out. All matching, non-matching rows, it is a full join. All the information, whatever available in the left side table, right side table, all the information will be kept, right? Whether it is matching or not, it doesn't matter. It is similar to one-to-one merge. Matching rows and non-matching rows from the first table. All the information in first table will be there, right? Which is important for us because we are working on the insurance data. Only information which is matching on the second table, that will be brought to the first table, right? See what is written: matching rows and non-matching rows from first table. Whichever matching rows in the first table, that will be there. Then also non-matching rows, right? Let's say certain state name is there for which latitude longitude is not there, right? That also will be there. It is not that latitude longitude is not there, that's why the rows will be deleted. Not like that, right? Other way around, uh, right join. This one is the matching rows and non-matching rows from first table is the left join, because I'm keeping the left table. Matching rows and non-matching rows from second table, that is the right join, because I'm keeping the second table. Whichever information is not there matching, right, in from the first table, those will be deleted, right? So that is about your different type of merging, right? Same thing what in, I think most of you there in the Tableau class. So the different join type: inner join, full join, left join, and right join. So here what I'll say, matching rows and non-matching rows from first table, because that is what I intend, right? My first table need to be there. Required match column, which column you need to match on, right? So for us, that is the state, right? On state, on the first table, the state parameter on which we want to match. So if I just do that and click run, right? So if you see the original insurance file, we have included the latitude longitude part also, right? original insurance table, which we have that age, gender, BMI, children, smoker, state. With that also we have included now two columns, latitude and longitude, right? So I can save this as my insurance, maybe for run it again. Okay, so now it is stored in insurance 4. It's not work insurance 4. So in my library PAUS 2021, I'm saving it as a new file, right? Because I've included two new columns there, right? It should be there. Let me just check. Here, now it has come. Okay, so this is the file where I have combined two tables, right? Insurance 3 file along with the latitude longitude data, right? Now why we created this? Because we wanted to create a visualization on Indian map, right? Other things again I'm leaving it to you. Go through it. If there are any doubt, we can check that, but I'll not go through each of them because our intention is not on the descriptive part of analytics rather than predictive, where we'll use regression data, decision tree, neural networks, all those things like logistics regression, all those things. So let me just try to create a bubble map. So my new file is insurance 4, that is there, latitude, longitude, bubble size, on which basis bubble size will be created, right? So we can create profit or claim amount, whatever are charges. Let's say charges. So it might take few minutes. Anybody who is not in this page. So if you see, if you compare, this is not like kind of as captivating like what we used to create in Tableau. But again, for SAS, this is not the highlight, or this is not something of their strong point. That's why they're coming up with the visual analytics. So there is a new software called SAS Via, which is actually kind of competing with Power BI and Tableau, right? But because this, but the intention is you can also carry out certain mapping or the map analytics, showing that what kind of sales, charges, profit from different states, right? Here basically average profit size or the charges are almost equal. That's why you are not able to judge the difference between different bubble sizes. Almost all are equal. If you have a good data set where there is a significant difference, right, bubble sizes will be different. Okay, so this is about your using map option in tab. Sorry, I'm going back to Tableau again in your SAS. Any questions or any doubt on this? Okay, so that is one thing I wanted to show. Okay, on the regression part, okay, let us first check into SAS Enterprise Miner, then if time permits, we'll come back here. Okay, before going to SAS, yeah.
So in bubble size, I'm not getting that charges option.
In the data part,
Yes, sir.
which file you have taken? The updated file?
Yes, sir.
What options are coming here in the bubble size?
So only latitude and longitude.
Okay, I think then you have taken this the file which I have given you today, right? So that file only
Yes,
three
yes,
columns,
sir.
right? No, we cannot create through that, right? So what we have done, we have combined our insurance file along with this file which I have given you, right? And we have created a new file. You have to use that file. Have you created a combined file?
Yes, I have.
Just check that you are selecting the correct file here in the data set.
Okay, okay. Yes.
Okay. So by the time she checks, and anybody having any issue who has not completed. So go to my libraries wherever you are keeping your all the work, right? For last through 2 3 sessions, we have starting working on that insurance file, right? So for me, let's say PAUS 2021, right? Ideally, it should have been 2022. Can I rename it? Not here. I don't think I can rename it. Okay. So here you go to the properties. Again, for me, it is the PAUS 2021. For you, it might be a different library name, which name you have given, right? Click on the properties, right? This path you copy. So select this path, right click, copy, right? Again, repeating, I had shown you to create library, right? And you had uploaded what we have worked on the previous sessions, right? So that library, right click on that, click on properties. So once you click on properties, this folder path option will come, right? For me, this is my username. This is my identity in SAS. Then this is the library path, right? Right click, select this and copy. Okay. So keep that, and we need to use that in our SAS Enterprise Miner, and I'll explain why we need to use that. Everybody has completed this. Anybody not completed this? Anyone? Go to the library which you have created, right click on properties, select the folder path, and copy the path, right? So we'll just try to explore Enterprise Miner today. There are few initial steps which you need to remember. That is the only thing you have to remember. Once you practice that, right? Balance as Enterprise Miner is like something like a what you can call creating certain PowerPoint visuals, right? Drag and drop, right? Here at least you have to search for options. There nothing has to be done. Everything will be given to you. Only the first few steps you have to remember. It is much easier than SAS Studio. So I hope for you SAS Enterprise Miner has opened. So I'm stopping sharing this and I'll share the Enterprise Miner screen. So this is the Enterprise Miner screen. Anybody who is not able to open Enterprise Miner? Anyone facing difficulty in opening Enterprise Miner? Okay. So like I said, these initial steps only you have to practice or remember. After that, it is only your exploration how much you can use Enterprise Miner, right? Because there is no coding involved. It is very simple to use. You just have to understand these first few steps, why you are doing this. Then it is up to you based on your interest. You can learn a lot of things, right? In the class, depending upon how many sessions. I am planning to have at least 6 sessions. We will not able to cover everything in SAS Enterprise Miner, but at least on the predictive analytics part, we'll cover everything, right? But there are many additional things. Text mining itself we can do through SAS Enterprise Miner. Some of you might have taken text analytics, right? Text mining itself can be done through Enterprise Miner. So, but again, that is not in the purview of this course. I'm not going to use that. But some of you, once you know that, you can use that also for your text analytics class. Okay. So click on the new project. Okay. Just click on next. So let's say we'll keep the project name that we are working on, insurance file data, right? Insurance one. Next. Okay. So this is the workspace where you are going to work, right? So if you come here, this is the project which I just created, INS1, right? So there are three main things here, right? Data sources, diagrams, and model packages, right? Data sources is the file or the input file on which you are going to work, right? We have to select that or we have to upload that here, right? Diagrams here, diagrams I'll show you once I go there. The connection of different data points or different input file or the analysis what you are going to do, right? Once again, I'll explain that once I create a diagram, right? Model packages is basically if I want to save that as a model package or I want to run certain, let's say I want to run certain data exploration, then regression, parallelly I have to run a decision tree. So there are different model packages I can run, right? And I can save that also, right? So once you enter in this space, right? The first part always what you have to do, click on this program editor. Okay. Okay. Once you double click on this program editor, so this is the only thing you have to remember or practice. We are creating a library, right? In SAS Studio, what used to happen? We used to right click and create a library and we used to give name. Here, that option is not there. We have to write 2 lines of code, not 2 lines, maybe few words only, like leave name. So I'm asking SAS Enterprise Miner to create a library. So I'm asking leave name. What is the library name, right? So I'll tell PAUS 2022. Let's say here I'll create a PAUS 2022, right? So this library it will create, right? But library where the data will come from, right? Because library cannot, we cannot upload data here like we can do in SAS Studio. So what I'll do, anything I want to work on SAS Enterprise Miner, right? I'll upload data in SAS Studio, right? Because I can upload data there and I'll access that data from Enterprise Miner, right? So that's why the path which I've created, I've taken that copy pasted, right? That I'll put it now under double quotation. Then I'll write okay. This is the only thing you have to write. Why access read only? Because I do not want to work on the file which is stored there, right? I do not want to make any changes, right? So that's how I told access read only, right? Everybody has written this. Anybody having any issue? So again, I'm creating a leave name. Leave name is I'm providing a name for that library. Similarly, where I created in the SAS Studio, PAUS 2022. Then what is the path? I've given the path access read only run. Select this, click the run button. So an error occurred. Error in the leave name statement. Okay. whether the path name was correct. Okay, I think I have taken the library path. You have to take the folder path. Where is my SAS Studio? Go to the SAS Studio, the folder which you have created, right? Just a minute, let me stop the sharing. Let me go to SAS Studio. Okay. Path name is same. What is not running? For any of you, it ran? Any of you who is following me? Semicolon is there most of the time. That is the only issue. Semicolon round symbol is there. Okay. Sorry, spelling mistake. Now it should run. So it has created a leave name and it has run, right? So now once I do that, copy paste this, whatever you had written, just select this two line, copy, right? Go to the project start code. Okay. Click on this, put here, run now. Okay. Now I'll go to data sources, click on data sources, create data source, SAS table next. Now let's see whether my library is created, right? So this is the library which I had created, PAUS 2022. If you double click it, right? Under this, the SAS files which we are creating on SAS Studio, right? All are available here, right? Because I have given the same link, same folder link here, right? So I'm going to work on any. I'll just want to show you today. Let us take the new file insurance 4. Okay. Next. So there are different options to change the data. If I come here, right? So what is the missing percentage threshold, right? So generally 20% is the threshold. Those things I can change. Reject variable with excessive missing values, right? Let's say there is a column, right, where a lot of missing data is there. Whenever you collect survey data, right, lot of times what happens, people, for some questions people do not answer, right? If you are in certain situation where lot of missing data is there, right, and that threshold you have to mention. Like I said, many cases if missing data is 20%, right, we do not use that kind of information, right? Class level count threshold for a class, right, category, right, how many levels maximum can be there, right? Let's say in this case state, right, what happens, there are 28 states, right? So that you have to mention here how many you want to keep it maximum, right? Detect class levels, yes. Reject level count threshold beyond 20, whether you want to reject, right? So whether you'll keep it 20 or 30, right? Reject variables with excessive class values, yes. So you can put it no also. No, I do not want to reject. Database pass through, yes. So basically it will like kind of go through the information what you have stored in your SAS Studio, right? So most of the times we will not be using that, but in this case, because that is the standard which has been set, what will say that reject variables with excessive class values, because we have a state, right, where I think we have more than 20 states, right? So we'll put okay, put next. So now this is the important part where you say that which is my input variables, which is my target variable, right? So in this particular case, let's say I'll just show you logistics regression, though we'll not get into the details how what are the variables for how the things, but I'll show you how to carry out logistics regression, because linear regression I've already shown you in SAS Studio. So in logistics, what we basically do, right? Logistics regression, your output variable, right? Or your response variable, right? Or your predicted variable, right? Is basically kind of 1 or 0, right? Whether this or that. We want to find whether somebody will take a loan from us or not. In this particular case, insurance, there is a insurance where there is a column which says that whether somebody will kind of claim or not, right? Insurance claim, yes or no, right? So that is binary, 1 or 0, right? Whether somebody has claimed or not. So in the other case, when we run linear regression, what we want to predict? The profit amount or the charges amount. Those are the continuous number. Here it is a our binary output, right? Whether somebody will take a loan or not, whether somebody will claim insurance or not. That is what we want to predict. So this is binary rather than input. What I'll say here, target, right? So this is the health category, right? So apart out of category and BMI, I have to keep one. I cannot keep both, right? Because category has been derived from your BMI data. So this currently I will reject it. I'll not keep in my data analysis. Claim amount, not necessary, but again, like if I use this also, not an issue. Latitude also not required because that won't define. Longitude rejected. Profit. So it is vice versa. One somebody is claiming, then only it is decided by profit amount. Profit amount will not decide the whether somebody is claiming or not, right? State, let it be there because it might affect. I do not know. Age, yes. Whether somebody's age might decide whether somebody is claiming or not. Age is input interval variable. State is nominal. BMI input variable interval. Interval means continuous data, right? Charges also, because once somebody okay, charges may be the amount of money they have paid, right? So that is there. What else? That I'll keep it, right? How much money they have paid till now, right? It might happen that somebody who has paid a lot of money, he starts claiming also, right? Number of children input, not nominal, it is again interval 0 1 2 up to 5 it is there. Insurance claim is target. Gender, yes, input binary. Smoker, yes, input binary, right? So this is the task you have to do. Again, if you forget also, there are like kind of later on also you can complete the task. It is not that here only you have to complete the task, but it is better in the beginning itself you are taking out time to kind of understand your data, right? What else? So here basically you can put label if certain additional information is there, right? In certain data set, it will show that what does category means, what does claim amount means. If you click that, it will show here, right? But in our case, it was not there. Just put next. Do you use to create a sample data set? Sometimes what happens if you have a very huge, large data set, right? Rather than starting, because right now we are just kind of exploring, right? Rather than using complete data set of 2 lakh rows or 1 lakh rows, right? You can take a sample data set, pilot a model, see that whether your model is working or not, then go back and run the model in the complete data set, right? In our case, it is a small file, 1338 rows. So we don't want to create here. So here again, name, all those things I can change, right? So there are different type of dataset also. We are not creating here training dataset, validation, testing dataset, scoring dataset, right? Later on, I'll show you how to create, how to divide these dataset into different training, validation, and testing dataset. Here we are just taking as it is. We are not creating a division, right? But that is important. Creating training, testing, validation, because we are trying to predict. It is not that we are exploring data, right? That I'll show you, and that is very much important, right? We'll create a data using training data set, validate it, then test it, right? part of the using the part of the data. Okay, so click finish. Once you see that, now your insurance file is there, right? Click on this diagram, right click on create diagram. Again, name I'll give, let's say the same name, insurance 4. So now once you click on this, see all these things are highlighted, right? Our main focus to reach here, right? To reach here, those are the steps which you wanted to complete, right? Today it might look like a lengthy process, but once you practice, carry out 2 or 3 times, right? Writing that name only, that is the first step. Leave name, the folder or the path or the library name, and the folder path name you have to give, right? That is the only thing you have to write. Other than that, it is only as click on the next step, right? So again, in the slide, if you see, I have given the details of each of these, right? The slide which I have shared, I have given detailed information. Again, I have taken that from the SAS site only, nothing new. So if you see, there are a lot of options which are available, which can not available in the SAS Studio, right? Like text mining, right? Which you can carry out through your SAS Enterprise Miner also, right? But most of our focus will be in this kind of modeling part, and some towards the end we'll do a credit scoring, right? Remember what we discussed on the first or second session, right? One of the key activity of banks, right? Analyzing data, customer data, and carry out this credit scoring. So they have already created a module for this, right? That's why SAS is mostly used in finance services, right? They have a specific module to carry out credit scoring. So mostly once we have this data, right, we'll try to explore it. So this is known as the SEMMA architecture of SAS Enterprise Miner. SEMMA S, that is sample, E, explore the data, transform the data. Okay, transform will come from the modify also. Here also you can modify the data. Then name modify data. Let's say I have a kind of population data in millions. I can transform it to billions or maybe in lakhs, right? The way I want to transform. Sometimes I have to transform data in logarithm scale, right? All these things can be carried out here. Modify. Model is the area which is in much more interesting to us, because there are different type of models, starting with two-stage kind of regression. Then you have rule induction, regression itself, the linear regression, partial least square. This is the regression what you are using as ordinary least square. There is another method called partial least square, neural network. So that towards the end of our class will do. Model importing, not a kind of a modeling itself, because if I've created certain model in SAS Studio or some other kind of area, can I import it and use it, right? Memory based reasoning, I have not used that, to be honest. So not much knowledge in this how that is used. Least angle regression, again it is a part of, there are different type of regression, ridge regression, lasso regression, Lars regression. These will again will cover under regression. This again will cover gradient boosting, right? One part of your decision tree. Once we understand decision tree, there are many ways to kind of improve the model, right? Random forest, gradient boosting, all those will come under that. An assemble method, right? Which is basically random forest and an assemble method. Data mining neural, so that is again kind of the neural networks what we have discussed. Again, D-mine regression, decision tree, and auto neural network. So mostly these are the few modeling techniques we'll study. Regression, different type of regression, which include logistics regression, lasso, reach, Lars, right? Then decision tree, then under decision tree, an assemble method, gradient boosting, random forest, then neural network, right? Then we'll study something called the market basket analysis. That is basically to understand, or the collaborative filtering. If somebody is purchasing certain items, what is the guarantee or what are the chances that they also will purchase certain other items, right? So those are the some additional things which we are going to use. Of course, the credit scoring part, right? But just to have a glimpse of what we can do, how to carry out any analysis, the first step is to drag this data source, right? So whichever data source you are working on, in our case insurance 4, click that, drag it here, right? So just check that if there are any issues. Yeah, like I said, if you want to change any role, right? Where is this? Not here. Okay, variables. Click here. So here, if you see, if you have not done that step, different variables, what kind of variables I will use for my model, right? Here you can change this kind of information, right? I'm going a little quick because anyhow we'll cover this later on when we come back to SAS Enterprise Miner. Today my aim is just to show that explore SAS Enterprise Miner, right? So you can do data partition, you can do training testing data here, import an external file also, but I think that in the academic version doesn't work properly. Then filtering data, some information, let's say I want to take out the outliers, the age which is below 25 or age beyond 60, I want to exclude those kind of information. So data filtering can be done. So here again, like the variables what I said, for my I can just take this input data and say that okay, these are the out of this large data set, I'll use only these 20 columns for my modeling, right? So insurance file, let's say I have 9 columns, right? Out of that only I'll use 3 or 4 columns, right? Don't worry about it, I'll come back again, we'll discuss this when actually we use it. Today I just wanted to show you the explore part, multi-plot. Where is this? Okay, market basket analysis also will do like I have suggested. Multiplot is basically the data visualization tool, right? I just want to understand what my data looks like. So I dragged this, I clicked on the multiplot, drag this here, click this, connect to multiplot, right? Right click on multiplot, click on the run button. So if you click on results, so you'll get counts like this, right? Different state. So this is the state data, age data, how many variables, BMI data, charges data, children data, insurance claim data, how many claimed, how many not claimed, smoker data, right? So this kind of multi-plotting for your whatever your information in that table is there, right? You can carry out, and so here also you can find out the missing percentage, right? Missing percentage, non-missing percentage. Just a moment. So how many from different states, right? Andhra Pradesh 100, frequency of that data over total overall data, right? Age, what is the minimum value, maximum value, mean, standard deviation, skewness. So basically all the basic descriptive data information will be available here, right? So that's about it, right? So just a basic data visualization and descriptive analysis through Enterprise Miner. Now let's say I want to create a model, right? So whatever we carried out in our SAS Studio. So I'll go to model, click on this regression. So this same model, same kind of package, we can use it for both linear regression and logistic regression. So again, click on the input data path, click on the regression, link it to regression. So here again, you have to choose certain things. What kind of regression you want to run? Logistics regression, because our target variable is yes or no, binary, right? Whether somebody will claim a insurance or not. So here again, we'll come back and see that what kind of statistics we want to understand, confidence limit and all those things. Today, I'm not going to select any of these, but there are a lot of options when we discuss logistics regression, right? How to kind of improve our model, right? We'll come back and look into this. There is also different technique of optimization. So there are, so if you go through it, there are different type of optimizing your model, right? So we are using the default model, which is for the both SAS Studio and Enterprise Miner. Again, we'll come back when you discuss the logistics regression part. We'll discuss in detail. So now only thing what you have to run is click on regression, run. Okay, must use one target variable. Okay, I had selected target. Okay. That has become input here. That's why the issue has happened. Yeah, we need to have at least the output variable, one output variable, right? No. So once you run it, the mistake which was done, that what we had selected at the target, right? Automatically it has gone to the input variable, right? To run a regression model, at least you need one output variable, right? So this is the result for your logistics regression. So here the main important thing is we have to understand the odds ratio and how to interpret that, right? So odds ratio of different states, smoker, non-smoker. So whatever number of children what we have taken, right? So this has been calculated, then the fit statistics is given. So when we compare different model, let's say I create the same input data and use that a logistic regression or a decision tree, and I want to compare both the models, right? So these are the statistics which will help us to use, right? If both are performing same, based on these statistics, we'll be able to kind of compare the models, right? Mostly the root mean square error and mean absolute percentage error, all those information. Base classification rate. Then this is the event classification table. Some of you might know how to construct it. Again, that is already given. We'll try to understand it, right? So this is about your usage of kind of SAS Enterprise Miner, right? So the only thing why I showed you today, again, we have not gone into the detail of Enterprise Miner. Try at least to open SAS Enterprise Miner and create a workflow, right? So that will give you a lot of confidence that, okay, I know at least to use the tool, right? How to use and how to interpret the data, right? How to interpret the results. That is what we're going to cover in next whatever sessions we have, right? Till your end term. So both through SAS Studio and Enterprise Miner, right? Because running the model is easy. It will take few seconds, right? We're not doing anything much. We're not writing any code. But how to understand those models, right? What those results I showed today, how to interpret that and how to make business sense out of it, right? So from your side, what I will expect is at least you know how to run model, right? How to run SAS Studio and Enterprise Miner. So when I am doing parallel in class, right? So not much difficulty is happening either from your end or from my end, right? So just quickly I'll go through the few of the slides. Intention is not to go through all of them, but again main. So we have discussed how to create a data in SAS Studio, right? This part we discussed on the SAS merging of SAS information, right? SAS tables, right? Whether it is a inner join, when it will show that, okay, only the information which is available in both the tables, both the files, let it be there, and other information, let it be thrown away, right? All rows only in table in, but not in table B, right? Whatever information is available in table A and common information in B, let it be there, and other information be thrown away, right? This is full outer join, except the common part, keep all everything, right? So that is what different type of join: inner join, outer join, then left join, right join, full outer join, right? Again, like this part already we have covered. To create a code so that we are creating this profit was not there in the initial kind of your data set we have created, right? If some of you have missed the class, right? So this is the code for it, few lines of code which you had written. This part I have not done, but if let's say I have created a column, I want to drop it, rename it, right, in the file, right? So there are different options. Let's say I want to rename state to states. I can just write rename state equal to states, right? If I want to drop, actually I have not created this variable this time, but let's say I created that category variable, right, for BMI category. I want to not use that, right? I can drop that also, right? Drop that variable. One advantage of SAS is you do not have to remember the, like, because in Python when you are writing you need to remember the hierarchy of it, right? Lines cannot start from anywhere, right? There is a proper sequence of writing code. Here it doesn't matter as long as you are putting a semicolon at the end, right? That is the only important thing. Obviously the spelling mistake, right? Today access spelling I had a mistake and that's why the code was not running, right? So that's why several statements may be on the same line with each statement with a semicolon. It doesn't matter whether one line or several lines. So one line it will run as long as you are putting a semicolon at the end of the code. Blanks as many as you want, but at least one may be used to separate the components words in a SAS program statement, because I cannot just type. Basically, one space is required between any statement I'm making. Let's say leave name. Continuously, I cannot write leave name without any blank, without any space, the folder path or the with whatever I want to create. Case, there is no importance, lower, upper. If I write data set, leave name, whether I write small letters, cap letters, statement remains same, right? There is no difference. Case does matter in data and quoted information, but it statement it doesn't matter. Let's say if I write set, ACT or data, small or caps, it doesn't matter. But if I'm writing the data set name, because there might be data set means small letters and caps letters also, right? Let's say aim for male in your variable name, right? So that's why I told, like, when I'm merging two tables, column name need to be perfectly matched. If somewhere it is state and other case it is states, it will not match. Moreover, the contents of a title footnote are placed in quotation mark. Let's say you want to give a, I'll show you that. Let's say I want to give a that, let's say I'm running on a regression. So for that output results, I want to create a Word document which will be titled let's say linear regression using insurance data or linear regression for insurance, right? So if I put in double quotation, right, the title name will come. I'll show you that later on. Common errors. Every time you are writing a SAS program, right, at the end you have to write run semicolon. And this is what I've already talked about. Most of the times, if there is any issue in your SAS program, just check that semicolons are you have put semicolons everywhere, right? That means at the end of the line, right? That is the most common mistake, followed by if you have forgotten the run symbol. Unmatched quotation marks. If you are putting a quotation marks, make sure that closed quotation mark is also available. And always start with the first error, right? Once there are a lot of errors, let's say you run a program and errors are showing, rather than going from below, right? Because what happens if I kind of rectify one or two errors in the top, other errors also will go away, right? So whenever you are reading that log file, start checking what are the topmost error. If you are able to correct that, most of the times other errors will go away, right? So those are the few things. Then on SAS Enterprise Miner, what we discussed today, right? Transform input data I have not shown you. I'll show you in the once we discuss on the apply analysis general deployment methods, right? This is where you are creating the diagram, right? Different type of logistics regression decision tree. So once I show you that, it will be much more clear. What actually is one advantage of Enterprise Miner is the comparing models, right? If I create the same prediction using 2 or 3 different techniques, and I do not know which model is working better, right? So this is where Enterprise Miner is little better. Obviously, that I now SAS Studio also has option. Earlier they did not used to have, but Enterprise Miner from the beginning they have that option, right? Where I can compare models, right? Because that is something again we have to learn, right? Because when you're deploying towards the production, right? That based on that management is taking certain decisions. That should be our champion model. That should be our best model. And how to understand or how to convince someone that this is our best model, I have to show certain numbers. Okay, on these parameters these 4 models were compared and this emerged as the best model. Let's say for certain cases decision tree might work well, for certain cases linear regression might work well, for certain cases neural network might work well, right? We do not know, and without running nobody can say that okay for this data particular model will work, right? All the 3 models will give you results, but which of them is the best model, which one you should believe on, right? So that capability kind of where is available on the Enterprise Miner, where you can compare models. Then obviously production system, once I know that okay this model is the best, we can deploy it, right? So generally if you see look into the credit card companies, how do they do it, right? So they create credit scoring, but again this is not 100% perfect. So they will have accuracy rate of 80%, 82%. Based on that, they deploy that. Based on that, they start giving loans, they start kind of increasing credit limit and all those things. And how the market reacts, how the customers react. So those again, some people might start kind of defaulting in their loans. Some people again might take more credit card. So that information again is coming back to the database, right? Whether it is Citibank or American Express, those information again coming back to the that company, right? Then they so that results based on whatever data analytics you have done. Let's say I created a this insurance data set I used, and I created a my model suggested for smokers we are on an average we are basically losing profit of 2000 rupees or 3000 rupees. Remember what we did that linear regression, smoker versus non-smoker profit amount is decreasing by 3000 rupees. So now what we'll do, we'll charge 3000 rupees more for smokers on premium amount. So anytime a smoker comes for insurance versus a non-smoker, for a otherwise other way around the marketing trick will be stop smoking so that you can save 3000 rupees on your insurance, right? So that is way to kind of motivate people to stop smoking, right? So anyway, let's say this is our campaign, right? Based on the data analytics we did. Then we'll start getting the information. Now, how many smokers have joined? How much premium we are earning? Whether we are making profit or loss, right? New data set will come. Again, that will be put on the model which you are working on, right? And we'll see that whether the model which you were created earlier 3 months back or 6 months back is still working on the new data, right? So it is not a one-time job when you are creating this analytic model for anything, right? It is a continuous process. You created a model, it worked on the data, both on your training data and test data set. Now you are launching whatever marketing campaign or whatever insights you gave. So let's say they will charge 3,000 rupees to smokers, right? Based on that, whether your company's aim is to increase profit, whether company's profit increased or not, right? Now for next 6 months, you collect data. Again, those new data will come back and you'll see that with your existing model, whether your data is giving the similar results or not. If not, data is not incorrect, data is coming from the market and we are assuming that information is being captured perfectly. Now you'll see that okay, my model is not working on the current data, new data, which then you have to modify your model. So it is a continuous process. You build a model with a existing data, you give those insights. Based on your insight, there will be marketing campaign or there will be certain steps taken by the management. Based on those steps, let's say I wanted to increase my revenue, increase my profit, or decrease my cost, whatever the step may be, right? Then new data will be collected. We come back and again analyze, see that our current model is working or not. If not working, then we have to improve our model. So this cycle keeps going, right? Assess, observe results, and refine analytic objective. Now, if you have made that, then you might say that, okay, let's see what else we can do. If you're not meeting that, again, we'll go back and run the new model, right? So this is how the complete process works. So this is the like different shortcut buttons which are available, right? So this is the working space where we'll create diagrams in the enterprise miner, right? This step is the project panel, right? Where you give a name for the project. There is data sources, diagrams, model packages, right? Here, remember to include that path in the project start code. Again, I'm not going through one by one because it is not something theory which I have to like kind of remember. Only through practice, I am giving you the screenshots in the slides so that once you do carry out that in your home, right? You remember these are the some properties of SAS Enterprise Miner, right? So this is the main path or the main workspace diagram workplace where we will be working, right? So this is a census data which is available in the SAS Enterprise Miner. We need not upload it. So they have filtered it, created a transform variables. So some variables they have transformed. Let's say they have put a logarithm transformation, square transformation, some information there. Age is there. Rather than keeping age, they are just squaring it, right? Then cluster. Toward the end, they are run the clustering algorithm. So again, this is the process flow, right? So process flow is the basically that SEMMA architecture, right? Sample, explore, modify, model, assess. Assess model means compare different models which works better. So this is the toolbar. This is the SEMMA process flow. Sample, explore, modify, model, assess. So computing predictive models. So there are different models which will create, then compare and say that, okay, out of these three models, this is the best model which is working for us, right? So these things I'll not go through. These are the again definition, what exactly this all those symbols or what kind of analysis, data exploration, data visualization we can do. So again, I'm not going to go one by one. This all the information is available on the slide. You also need not have to remember all these things. I'm not going to ask question what does this symbol means. I have given you so that you know that these are the activities we can do in SAS Enterprise Miner. All of these things obviously we will not able to complete, but at least maximum of them which will be useful for our predictive analytics, right? We'll come back and complete those, right? So there are different options which are available on your SAS Enterprise Miner. I have already shared this slide, right? So keep with you whenever you are working on SAS Enterprise Miner, it will help you, right? If you forget that, okay, what is this, right? So I have again taken from the SAS help, right? Nothing new, not that I've created that on my own, but it is a single repository where you can look and if you do not know exactly what the symbol does, right? You can refer to this document, okay? So before we close for this today's session, right? I have a simple question. What do you mean by this linear regression? Because from the next class, we are going to next 3 to 4 classes, we'll focus on linear regression and logistics regression, which is one of the important part of predictive analytics. Not only the linear regression, we'll cover the different other type of regressions, what I told today, right? But before we jump into those discussion in the next class, simple question, what do you mean by regression? Anyone?
Sir, in regression, we basically try to see if there is any relation between two variables. And if a relation exists between them, we are trying to predict the dependent variable based on the independent variable.
Correct. So that is about the linear regression part. So I have 3 equations written here, right? Which of them are linear regression, which of them are not linear regression? So y is one variable, let's say that is my dependent variable, x is my independent variable, a, b, those are constant, right, or beta values. So this star symbol is basically multiplication, right?
So 1 and 3 are linear regression and 2 is logistic, I guess.
Okay. So you are telling this one is regression. Okay. Anyone
1 and
else?
3.
Okay. So this you are telling again logistics regression. Okay. Anyone else have a different answer? So why this one is linear? Y is equal to a plus bx square. This one is simple. This I think all of us we have used, right? So this is not a, this is a no-brainer, right? So this everybody knows. This is in a linear form. Y is equal to a plus bx. The doubt happens in these two. Y is equal to a plus bx square. Y is equal to a plus log b. Okay. Anyone? Unless I told this is linear, the first one, and second one is logistics. Forget about third one. Third one, I think all of us know that that is linear.
The first one I think is not linear because the power is raised to 2.
Okay. Second one?
So I think second one, so log is there. So that I am not sure about.
Okay.
Sir, in linear, our values can vary from like minus to plus, but in logistics, the values remain only between 0 and 1.
Which value?
The y value, whatever value would come, that would remain
Correct.
between 0.
Correct.
So that is why I assumed the first one to be linear.
Okay. Any other answer? Amog is telling the first one might be not be linear. and second one he is not sure. Any other answer? Because that will like kind of take us to, because we have just run a simple or multiple linear regression in the last class, right? Obviously we did not discuss the values in detail. That will start in the next class. Also we look into the transformation of the variables, right? Different transformation of the variables and how that impacts your regression, right? Just to like kind of give you a thought for the day, or when next class we'll discuss that again, why I've written these two in different formats. Let's say I have this internship, monthly internship amount, right? How much your last senior batch kind of earn staying at home online internships, right? And their age group, right? So if I plot this, right, the amount of money monthly online internship, what they earn, and the age of your senior to senior batch student, right? So I'm getting equation something like that. I have not run a complete model, just trend line, and it is saying y is equal to your whatever the internship amount they're getting, 162.15 x is this value plus 3000, but r square value is very poor. It is because obviously I've just, this is not the actual data, I've just put these numbers, so that's why it is not much relevance, right? R square is equal to 0.11. Now somebody says, why don't you kind of create a new variable called x square, right, and take the square of this age, right? This is age, this is the money, this is the amount of money. So once I do that and try plotting that, right, I have a new equation, 7.0412 x, here doesn't mean x means here x square, because that is my new x axis. Y is equal to 7.0412 x plus 3000, right? This 3000 I have kind of forced it that should be the intercept, right? But r square value suddenly increases by 0.8 percentage around, right? So it was 11 percentage here, 0.11, here it has become 0.19, right? Why do you think this happened?
Yes.
Or, and why do you think? Because this is almost equal to your, if you see this format, right? I have a constant 3000 plus 7.012 x square. Here x is actually my x square, right? So why do you think this, whether it is a linear or non-linear? Because if I say here x is not actually x, right? X means here x square, because I have converted that original x to a new variable, that is x square. So that is taken here as x, right? So still if you see, if I have a linear kind of relationship, right? So why this is happening? And if this is true, then I can say that this is linear, right? Then what is the problem here? What is the problem in our understanding? How to call a whatever equation, whether it is a linear regression or not, right? Obviously we'll come back to the logistics regression part, right? Amog, is my question clear, or is the confusion which I'm creating is clear or not?
Yes, sir. So you are trying to say that we have taken x square as x in the linear regression.
Yes. So in this particular case, what I've just done, rather than taking x here, I've taken just x square. So that's why if you see the plotting which has happened, y is here and x square is my x axis, right? So the actual equation here is actually 7.012 series is x square, right? 7.012 that original x square, right, plus 3000. So just imagine that situation, right? You have internship, paid internship amount, and somebody student's age. Now you will say that, okay, I'll not take age, I'll take square of the age and see that whether model is being created. And you will observe something like this linear relationship between your income and your square of your age, square of the age of the person, right? So in that case, can I call it as a linear regression? So I'll leave you all with this kind of doubt. We'll discuss that in the next class. Then we'll get into the different types of linear regression, right? So what I'll suggest or at least request that at least have certain understanding or revision of the linear regression part, because again, I don't want to get into theory. It will eat away a lot of our time. Some things which is very essential, I'll cover that. Unless some of you ask that, okay, I do not understand this, I'll assume that you have covered linear regression in your earlier kind of third semester or in the past year. What we are trying to find out the little advanced version or different type of linear regression and how to kind of use that in SAS Studio and Enterprise Miner, right? Again, I'm open to again suggestions. If some of you want to cover something in detail, I can cover that. But my assumption is that our focus will be on the usage of SAS Studio and Enterprise Miner, and also cover everything which comes or whatever possible to cover within the short time, right? So that's all for today. Take care. We'll meet next week. Okay.
So I just missed my attendance. I joined a bit late.
Roll number 288.
So 288. Yes.
Okay. Anyone else?
Thank you.
Okay. Chalo, take care.